friends, in this video we are going to solve a problem on how to sketch the polar plot of a system. So let's take a problem. So our problem is to sketch the polar plot for the following transfer function, and the transfer function is given to us as gs equals to 1 upon s plus 1. So let's try to solve this. The first step to sketch the polar plot is to replace this s by j omega. The transfer function is given to us as 1 upon s plus 1. So it is already in the form st plus 1. Okay, here t is equals to 1, so it is already in st plus 1 form. So we have to just put s equals to j omega in this transfer function. Okay, so this was our first step. Now second step is to obtain the magnitude and the angle expressions of this transfer function. So magnitude will be is represented by m, and it is given by magnitude of gj omega. It will be equals to 1 upon omega under root of 1 plus omega square. Okay, so this is the magnitude of gj omega. Now the phase angle of gj omega is represented by like this, and it is phi. Okay, so magnitude is m and phase angle is phi, and it is given by the phase angle of this, that is numerator part, will be tan inverse 1 0 upon 1 and minus tan inverse of this is 0 upon omega upon 0 minus tan inverse of omega. Okay, because whenever we take the tan inverse of a imaginary part, if it is given like x plus j y, then it will be tan inverse of y by x. Okay, that is imaginary part upon the real part. Okay, so if we take the tan inverse of the numerator, then it will be tan inverse of, because imaginary part is here 0, so it will be tan inverse of 0 upon 1 minus because now we are minus sign, because we are now taking the tan inverse of the denominator part, so here minus sign will come. So tan inverse of omega upon 0, here omega is the imaginary part and real part is 0, so here we will be having 0, and here minus tan inverse of omega upon 1, because real part is here 1. So this is the phase angle. Now let's further solve it, because tan inverse of 0, it will be 0 minus tan inverse of omega upon 0 means tan inverse of infinity, so it will be 90 degrees minus tan inverse of omega. So the phase angle phi that is angle of GJ omega, it will be minus 90 degree, because this is tan inverse of omega upon 0, that is tan inverse of infinity, it will be 90 degree. So minus 90 degree minus tan inverse of omega. So we have both the magnitude and the phase angle relationships for this GJ omega, that is the open loop transfer function of this system. So this is our first equation, and angle, it is the second equation. So in these two equations, we will vary the value of the omega from 0 to infinity, and for different values of omega, we are going to find out that what will be the magnitude and phase angle for that value of omega. Okay, so we are now going to make a table in which the value of the omega, that is the frequency, it will be changing from 0 to infinity, and for that values we are going to calculate the magnitude and the phase angle. So let's form a table here. Now first take the value of omega as 0. Okay, now put this 0 in the magnitude and the angle expressions. So magnitude we have here 1 upon omega under root of 1 plus omega square. So putting 0 here, we will get the value of magnitude as 1 upon 0 will be infinity. So magnitude will be infinite. And here in this angle expression, that is equation number 2, putting the value of omega as 0, so it will be minus tan inverse of 0, it will be 0. So minus 90 degree will be the phase angle. So it is our first value of omega. Now second value, let's take omega equals to 1. So in the first equation, putting omega as 1, so 1 plus 1, it will be under root of 2, and here 1, so 1 by root 2. So the value of magnitude will be 0.7. Now in this second equation, putting omega equals to 1, then this phase angle will come out to be minus 135 degrees. Okay. Now taking the value of omega as 2, again putting this omega equals to 2 in the first and the second equation. So omega equals to 2, it means 1 upon 2, and 1 plus 2 square, that is 4. So 4 plus 1, 5, that is 1 upon 2 root 5. So when we solve this, the value of the magnitude, it will come out to be 0.22. Here putting omega equals to 2, so minus 90 degrees minus tan inverse of 2, so the phase angle will come out to be minus 153 degrees. Now next take another value of omega. Let us suppose it is 5. So putting 5 in the magnitude and the phase angle equations, 1 upon 5 under root of 1 plus 5 square, that is 1 plus 25, 26. So it will be 1 upon 5 under root 26. So the magnitude, it will come out to be 0.039. And here minus tan inverse of 5 and minus 90 degrees. So the phase angle will be minus 169 degrees. So now taking another value of omega. Now this time takes omega as infinity, because for sketching the polar plot, we have to vary the value of omega from 0 to infinity. Okay, so if we put infinite in the magnitude expression, so magnitude was tan inverse of magnitude here 1 upon infinity, so the magnitude will be 0. And in the phase angle, if we put here minus 90 minus tan inverse of infinity, so it will be 90 degrees. So minus 90 minus 90, it means minus 180 degree. Okay, so here we have varies the value of omega. Omega varies from 0 to infinity, and now we will plot this magnitude and the phase angle on the polar coordinates. So now let's plot this magnitude and the phase angle. This is the imaginary axis and it is the real axis. This is positive, negative, it is positive and it is negative. Now this is 0. Let's divide this or mark, choose a scale for the magnitude, because magnitude is represented on the real axis. So we have here 0, 0.1, 0.2, 0.3, we have 0.6, similarly 0.7, 0.8 here. Now here also divide the magnitude. Now our first point was omega equals to 0, and for omega equals to 0 our magnitude is infinity. Okay, so if we plot here, and for omega equals to infinity the magnitude is 0. So just plot all these points on this polar plot, and for omega equals to 0 we have the magnitude as infinity and phase angle as minus 90 degree. So this is minus 90 degree here. Omega equals to 0, magnitude is infinity, so it will be somewhat like here, okay, coming from infinity. Now for omega equals to 1, we have magnitude as 0.7 and the phase angle is minus 135 degrees. So just plot this minus 135 degree. Phase angle, it is represented on the polar plots as radial lines. And magnitude is plotted as concentric circles. So for this phase angle minus 90 minus 135, we are going to plot a radial line. So minus 135 will be somewhat like this. This angle is minus 135 degree. Because we are having the phase angle as negative, so in polar plots the negative angle, negative phase angle is measured clockwise. That is, in clockwise direction we are going to measure the negative phase angle. So it is minus 90 degree going in the clockwise direction like this. So it will be minus 90 minus 135 degrees. So it is minus 135 degrees for omega equals to 1. This was minus 90, omega equals to 0. Now for omega equals to 2, the phase angle is minus 153 degrees. So minus 153 degrees will be like here, minus 153 degrees for omega equals to 2. Now omega equals to 5, we have the phase angle minus 169 degrees. So let's plot this. It will be like this. minus 169 degrees, omega equals to 5. Now for omega equals to infinity, the phase angle is minus 180 degree and the magnitude is 0. So 0, we are having the magnitude here, and the phase angle is minus 180 degree. So it is minus 180 degrees. So omega equals to 1, magnitude was 0.7. So it is somewhat like here. Then for omega equals to 2, the magnitude is 0.22. Okay, so it is like here 0.22. Then for omega equals to 5, we have magnitude as 0.039. So it will be here. And omega equals to infinite will be coming from here. So if we join these points, then going towards infinity, because for omega equals to 0, the magnitude is infinite, so it will go towards infinity. So it is infinite, and we have joined the points. Mark these points. Okay, this is omega equals to 0. Okay, and this is omega equals to infinite, coming from here. So this, when we join these points, that is omega equals to 1, omega equals to 2, omega equals to 5, then by joining these points, the path which we have found out, it is the polar plot of the system, okay, whose transfer function is gs equals to 1 upon s plus 1. Okay, so for this transfer function, the polar plot will be like this, because polar plot is what? It is the plot of the magnitude and the phase angle on the polar coordinates, as the value of omega is varying from 0 to infinity. Okay, so what you have to do whenever such type of questions occur, that you have to plot the polar plot of a system. First put s equals to j omega, then find the magnitude and the phase angle relations, and then form a table where the value of omega is varying from 0 to infinity. Calculate the magnitude and phase angle for all the values of omega, and then plot this table, that is the various values of magnitude and omega on the magnitude and phase angle on this polar coordinates. So I hope this problem is clear to you. Thank you.